Hi, everybody. Okay, we are going to start first with the prize to the best dissertation in economic business and finance. This is the prize Enrique Fuentes Quintana. I think this is a prize to the best dissertation in economics that have been done in Spain for foreign and Spanish student and for a Spanish student abroad. So then, the first thing is the most prestigious prize because I think it's the only prize I know of this, and not only for that thing, because the goal of the prize is to promote excellence and to give visibility to our wonderful PhD students and their work. And it's a single opportunity just to highlight, for example, the wonderful, basically, job that they have done. For example, the one of this year on SAEe Way. It's also prestigious for the name, because Fuentes Quintana was one super influential Spanish economist for the one that you are very young or you are a foreigner. They have a huge impact basically in our economy, and also he was successful in have an impact over our politicians and to change a little bit the trend, and was a pioneer in diffusing the knowledge. And to give you some data, this prize started in 2004 with 16 dissertations, and the current year we received like 600 dissertations and 160 in economics. But we like competition, and then we want just to encourage advisors and PhD students to submit the dissertation. It's super easy. It's only one CV, a copy of dissertation in PDF, and a brief summary of it. And this is 5,000 euros for the student, but the most important thing is just to highlight their work. So this year we were fortunate because we have a wonderful dissertation. The title was Income, Employment, Health Risks, Methods and Application. The advisor was Manuel Arellano, and the wonderful PhD student was SAEe Way. SAEe, if you just have a minute.
Congratulations to SAEe, and I would like to thank FUNCAS for the support to the association. It is a great pleasure to have Michela Carlana here with us, given at the first keynote lecture. Michela is an assistant professor of public policy at Harvard Business School. She has several other affiliations, including CPR, JPAL, ISA, and Bocconi. She has publications in top journals, including QJE and Econometrica, and she conducts frontier research on extremely relevant topics such as inequality and education, with a focus on gender and immigration. Thank you so much, Michela, for being here. The floor is yours.
Is there a pointer? Sorry about that. Okay. I can get started. So first of all, congratulations on the prize. I feel like these are really important signals in general for the career, and I hope it will be a useful signal for the job market. So I feel like I will start with this broad encouragement on applying for this type of prizes. So today I'm gonna give a talk in which I will try to put together several papers that I worked on. I will try to put together several papers thinking about like stereotypes in the education context. And I'm going to show you like a little bit of like the evolution of my research agenda in that specific like area. So first of all, if we think about like gender stereotypes, we have that in most countries, actually women see slightly underperform in math in most of OECD countries. And this is actually still there, even in the last PISA report, even if the gaps are getting like smaller and smaller. What is very interesting to see is that these gender stereotypes, these gender gaps are actually wider in those countries where there are more stronger gender norms or like deeper gender stereotypes, and you could think about that in terms of like a female labor force participation or implicit bias of the individuals. I'm going to come back of like what we do in order to measure implicit bias, but this is not a new research finding. This is actually coming from a paper in economics from Guizot and some co-authors from 2008, or like from some evidence in psychology from Nosek and co-authors. On top of that, and today in the morning we actually had in the education session very interesting paper more broadly across countries pointing at that, women are also systematically less likely to be represented among highly profitable fields in the STEM domain. So thinking ahead about like a broader, this broader pattern, we could think about how employment opportunities and like actually wage growths are raising more rapidly exactly in those occupations that are STEM-oriented, but it requires a combination of skills. Not only, and this is mainly coming from the work of David Deming, one of my colleagues at the Kennedy School, but like these requirements do not ask individuals to only have math skills, but a combination between math and social-emotional skills or like ability to teamwork. And these are type of like tasks that are really complementary and where we see the highest like wage growth in the labor market. And often, actually, when we analyze the data, we do see that women tend to have a higher like social skills, but they have like lower participation in the STEM workforce. But what we need and where the works is like the work and employment opportunities are growing the most is exactly at this intersection. And so this will be like a theme that will come back in this keynote, because this is the intersection we need to really work carefully on, thinking about how can we increase participation of in STEM, but also make sure that we develop social skills, because they do have like a very important implication for the labor market. So this is like a graph. Some of like the research, actually most of the research I'm gonna talk about today is actually coming from Italy, but like the pattern is like very similar across different countries, and this is part of like a very large effort that we do. And I know that in Spain you are moving exactly in that direction to try to get like the administrative data merged across like different Ministry of Education, different institutions, and being able to analyze large amount of data. And I really think that this key combination of thinking carefully on how can we use these large administrative data to try to help individuals address important social issues like gender stereotypes in STEM is like a really key and a discussion that should be like a key in the policy domain. And I'm gonna conclude with like some ideas and some work in progress that I currently have that really go at this intersection, thinking about how artificial intelligence and combined with like the access to large data could really be a step forward in addressing this gender gap. But this is like a very simple, like sort of like motivating graph that was possible only through this like a large partnership between different like entities, because this is coming from the National Evaluation Center, that is a separate entity compared to the Ministry of Education. And here you see the share of students that are actually in a scientific track in the Italian context in high school. And you see for the same performance in the standardized test score in math, you see take the top decile, you see that systematically women are underrepresented in STEM with the same ability in the standardized test score. And the gap is like so pronounced that you can add like as many controls as you want. This gap will still be pretty large and present there. Now, what I'm going to do today is divide this talk into parts. In the first part, we're going to think about how the exposure in our society to stereotypes could affect individuals' choices of the field of study, or even individuals' performance in math. And I'm going to use two examples, or focus on two areas. So the first one goes back to my market paper, thinking about the role of teacher stereotypes and how they affect the student outcomes. Then I will move on and think about beyond the teachers. These are only part of the interaction, but thinking about the role of peers and analyzing in particular how exposure to peers could affect the choice of field of study for women in the STEM fields. In the second part, I will think ahead and think, okay, which kind of policies can be evaluated in order to try to decrease these gaps. Before we move on, I wanted to give you a conceptual framework on how to think about stereotypes. If you take Bordalo, Genaioli, Schleifer work on stereotypes, they actually have this very nice QJE paper called Stereotypes. They define stereotypes as the overgeneralized representation of differences between groups. The intuition is pretty simple. If you take women on average are doing a little bit worse in math compared to boys, but if you take the top of the ability distribution, so the top quantile, we have an over-representativeness of boys in the top quantile of the ability distribution compared to girls. This may generate some stereotypes that then apply more widely to the entire distribution. So we could expect women overall to do way worse compared to actually what they do in the STEM fields. And so why do we care as economists, or why do we care as economists? Stereotypes, well, they seem very important in different dimensions. So first, if exposure to stereotypes lead to actual discrimination. What does it mean for discrimination is when individuals with the same characteristics and performance get treated differently by their teachers or by exposure in the labor market. So the second reason why we should be concerned about stereotypes in our society is when they induce a potential self-fulfilling prophecy. What do I mean for that? Take our example, leading example for today, the gender gap in math. Even if teachers hold these stereotypes, but let's say in their grading or how they give the track recommendation, they actually do not differentially affect boys and girls, or let's say for boys and girls with the same ability, they give exactly the same track recommendation, or they give exactly the same grades. This will not be direct discrimination. However, in the way in which they interact with individuals, they may lead to a self-fulfilling prophecy with girls in this context that may start to associate themselves less with the scientific fields and decide not to invest in their further skill in the scientific field. And this is goes back to a long literature related to the Pygmalion effect that is a very simple idea, but unfortunately that find some evidence from the psychologists since the end of 1970s, where what they did was a very simple experiment. They did a standardized test score in the classroom, and then they randomized whether they told to the teachers that they randomized essentially who were considered the top achievers in the class. And what they did is follow up on the same student and see what was happening 1 year after. And those students that were labeled by the researcher as the high achievers ended up having much higher grade and performing much better, even if this was randomized. It was not really correlated with their ability in the test. So this seems to suggest that there is something in terms of the expectation of teachers in the returns of students that have deep implication on what is happening for students later on. There are two other channels that I'm going to touch upon in this presentation. So the one aspect is a potential social image concern. And so this relates to Leo Bursin's work I'm thinking about acting wife, for example, in their context were much older students compared to the one that are part of my research that is much earlier in life. But their intuition from this acting wife paper is that for MBA students, they try to signal less like undesirable, what could be considered undesirable trait, so the ability of like being ambitious. So women tend to signal less ambition when they know that their peers are gonna observe their choice, compared to when this is like a private information. And so we are gonna investigate how much this could be like a channel through which we get this emergence of like the gender gap in the STEM fields. Finally, the last aspect is another interesting point that I'm gonna investigate more deeper in one of the papers I will discuss today, and is thinking about how does the systematic association that we do have between field of study and the peers affect the choice of like the field of study of women and men. Systematically, when you enter in a STEM fields, you are aware that you will be interacting with like more males, and if you are a woman, you will be a minority among like the group of people in the group of people in your class. So in some sense that even if like you are very interested in STEM, you may dislike being a minority in the group, a gender minority in the group of peers, with the group of peers that you actually end up interacting. And in most of the cases, we can't disentangle this role of like being a minority in the field and like the desire of studying like STEM. And so this is exactly one of the channels that I'm interested in investigating further with one of the papers that I'm gonna present today. Okay, so the first paper, and here will be like the key idea is thinking about the role of teacher gender stereotypes and how they actually affect the outcomes of students. So ideally, I would like to study the whole exposure to society, to stereotypes in the society, but what we do is like focus on teacher, mainly because we are interested in getting like one step beyond the correlation and thinking about the causal effect of exposure to stereotypes on student outcomes, and in particular the gender gap in math, but also like educational choices and confidence of individuals. The method that I use in this paper is thinking about like as good as random exposure to teachers with different level of stereotypes. Now imagine this like a thought experiment. Two girls enter like the same middle school with the same initial like performance in the standardized test score in the same school with the same parental background. And one gets assigned to a teacher that systematically has a higher level of implicit stereotypes, and I'm gonna come back on how I define that, but like higher level of like implicit association between STEM fields and boys, and the other girl gets assigned to a teacher that do not have any implicit stereotypes. And think about the same experiment for a boy. So this is exactly the intuition of what I want you to have in mind, and this is what we're going to exploit from an identification perspective in order to understand how does the exposure to a teacher that associates math with boys affect both boys and girls in this context. This will somehow help us overcome like the first issue, that is the identification issue. Well, like the second key point is like how do we actually measure teacher stereotypes? And on this, I use like one tool that is developed by social scientists in 1990s that is called implicit association test. This is a pretty controversial tool. It has been like part of like a lot of debate, even among the psychologists themselves, and sort of like creating like two different groups of like people that were in support and people that were against them. I think as economists, and as I was using the implicit association test, and as like other economists have been using the test, is thinking about that as like a measurement tool that do not suffer by social desirability bias. And I'm gonna tell you why I believe that this does not suffer from social desirability bias compared to most questions that you could ask explicitly to individuals. On the other hand, is a tool that has a lot of like measurement bias inside. So you should really think about this being like an imperfect proxy of implicit stereotypes of individuals. And if you're thinking about using like this type of tool in your own research, I would strongly recommend doing that only when you have like very large samples, because of like all the measurement and the noise that is involved with this type of measure. So But like, what's like this test? I told you like it doesn't suffer from social desirability bias, as you have like in open-ended like questions. But how do we capture implicit stereotypes in this case? This is actually a task done with a tablet or a computer, thinking about associating like words in categorizing words in different like in different buckets. So you will have like a first like a trial part in which people get used to the test, in which you need to divide like names. Let's say, female names and male names. There is a clear right and wrong. You need to press the blue bottom on the right if, let's say, it's like a male name, and the blue bottom on the left if it's a female name. So this is like the trial part. You have a second trial part in which you have like field of study. There will be scientific field of study and humanistic field of study. And again, there is always a clear right and wrong. You just need to do this task as fast as possible, and this test records exactly how many milliseconds it takes for you to do like one of these associations. Now, the interesting part comes when we're doing the two tasks together, when we have both names and field of study together. And again, there is a clear right and wrong, because individuals are instructed to categorize the word given like the color. So let's say that the word is in green. You will need to press the blue bottom on the right or on the left, depending on whether the word at the center belongs to the scientific or humanistic category. You may have like names, they will be in white, and they belong to either female or male category. So again, there is a clear right and wrong. The interesting part comes because every individual does two types of tasks, what I define here as task A and task B. In task A, you will have scientific and female on the same side of the screen. In task B, you have scientific and male on the same side of the screen. This is very interesting because it exploits the fact that when we are associating words on the same side of the screen, if we have like a strong implicit association between the two concepts, it will be easier, you will be like less mental effort for our brain to just do that categorization compared to the opposite task. So essentially every time like they have 180 words, every time they touch the screen, we know which part of the screen, how many milliseconds, whether they did a mistake or not in the categorization that will be penalized. And this allows us to calculate a score that is coming from the difference, mainly the difference in reaction time, except for the penalization, in task A compared to task, in task B compared to task A. If you are equally fast in the two tasks, it implies that you do not have implicit association between the two fields. If you are faster in task B, when you associate males with scientific fields compared to task A, it means that for you, it's like a lower mental effort. You have like this implicit association that are stronger in the context. So all these like association actually added here like some of the correlation. So the correlation I find it like fascinating between the implicit association test and the a bunch of like observable of individuals. And this is like something that was a part of like a large debate among the social psychologists of what correlates or not. The issue is that in a lot of the studies there were very small samples, like most of the outcomes were recorded like as asked by to the individuals right after taking the IAT, and sometimes they were finding correlations, sometimes they were not. But here, what I'm showing you is the correlation with background characteristics or cultural trait. So for example, like one characteristic among math teachers that predicts the most the implicit association test is whether yourself you are a woman or not. If you are a math teacher teaching math, you associate less math with males. However, so here there are a bunch of other characteristics that I find like surprising in some sense. But for example, I was expecting that individuals that have a firstborn that is a daughter will have like less implicit association. And I was actually thinking about using that as an instrument, but like this is like not the case. So there is not strong support for that in the data. So the panel B shows you the correlation with like a set of like cultural traits and beliefs. So the first one, the column here, is like whether you are born in the North or not. All the teachers that participate in this like data collection are currently living in the North. So the type of student they get exposed is like more similar, but we have like 40% of them that were actually born in the South of the country. And you see that there is a pretty large correlation between being born in the North and like and like the implicit stereotypes that you have. Or like the female labor force participation in your province of birth, and these stereotypes that we actually measure today when these teachers are living in the north of the country, or like measure from the World Value Survey at the city level on, for example, like gender equality, a bunch of like gender equality questions. For the same question at individual level, when we ask them the same world value question to the teachers during our survey, we do not find any correlation between their own implicit stereotypes and these questions. And so I think this is like very interesting because this was part of the debate on why this measure is like problematic, and maybe there is no correlation. But this measure, especially if you ask to someone that is a teacher in the school context, will have a lot of social desirability bias in their answer. However, if you go back to the norms in the place in which they are born, you do find that these are like very strong, like and positive correlation. So here is the first result. So now I'm going to jump. It's a little bit a quick overview. I'm skipping a lot of like the robustness check for this like paper, but I'm just like I want you to have like the main picture from this paper. So the main picture is essentially that in the x-axis here we have this measure, this continuous measure of implicit stereotypes. In the y-axis here I'm showing the residual of the standardized test score of individuals. And what you see is that if you get assigned to a teacher with stronger implicit stereotypes, girls will be less likely to perform well by the end of like middle school. This is pretty large, and so the gender gap in math performance is essentially 33% larger in classes that have teachers that associate math with boys, if you divide in categories instead of like using the continuous variable, compared to like classes that have gender neutral teachers. So this is like a pretty substantial effect that is driven by your own like math teacher. So what is like even sadder, I would say, is that the fact for boys. Because in some sense, you could expect, well, maybe this teacher that has these very strong implicit stereotypes is extremely bad for boys, but is extremely bad for girls, but is helping boys, at least in that classes. But what you see here is a complete flat line. Boys are not responding even like positively to having like a teacher with stronger implicit stereotypes. So this generates a cost on girls and no benefits on boys. So these are like a similar results, like in a regression format, where I show you what happens if you end up like controlling for a bunch of characteristics. So we have like a class fixed effect, and we just analyze the gender gap within that class in terms of like a standard deviation. And you see that this interaction between the gender of the student and the teacher stereotypes is always like negative, no matter which amount of like controls I add, and actually is not much affected by the controls. Here there are always like class fixed effects that are collinear with the level of gender stereotypes of the teacher. Is a slightly different identification strategy because I'm thinking about what happens to the gender gap within the class when I have a class fixed effect. So the difference between boys and girls in that class, but actually the magnitude is giving you exactly the same like picture compared to what I showed you before. And what is even more striking that even when you control for the gender of the teacher, or like whether the teacher is born in the north, interacting with the gender of the student, the coefficient is like completely unaffected. In some sense, for example, having like you see this like positive coefficient here on having like a female teacher for female students, not even statistically significant, but this coefficient here, that is what we care about, seems like unaffected by that. Now let's move like one step ahead. So this was like the results in terms of like actual like a high school, end of middle school exam. But what happens in terms of like track choice? After middle school in the Italian context is like actually not that different from the Spanish context. Students get divided in different tracks. And so here I'm showing you the lowest track, that is the vocational track, that tend to be like very low quality in the Italian context, is like very far away from like the German system, where like the vocational track could have like a pretty high level of preparation. And what you observe is that we still have like around 17% of girls in this track but like this share gets like much bigger in those classes that are assigned to a teacher with like with one standard deviation more implicit stereotypes. So from 17.5 percentage point, it increase of almost 2 percentage point, between 1 and 2 percentage point for every additional standard deviation of implicit stereotypes. And there are actually 6 standard deviation between the teachers with in my sample that have the highest compared to the lowest stereotypes. There is quite a lot of like variation on that. There is like one last point that I want to make on this point, on this paper before moving on. So there is like these widespread results that women tend to be less overconfident in math compared to boys. So if you ask them like how good you are in math, they will be way more likely to say that they are less good compared to actually the objective measure of performance. I say like less overconfidence because everybody tend to be like overconfident in general, but like women tend to be like less overconfident in that. So this is why like we often observe in this measure like a gender gap. So here you see that like similar results. So this is like in the first 4 columns, I'm controlling for, actually from column 2 to column 4, I'm controlling for the baseline standardized test score. And I'm asking them like, how good do you believe you are in math? And you see that when you are assigned to a teacher with 1 standard deviation more implicit stereotypes, girls became like a 5 percentage point less likely to say that they are good in math compared to boys. And like the overall effect was like a 10%, almost like a 9 percentage point of difference in the raw data between boys and girls, and just 1 standard deviation was explaining a lot of like that, of implicit stereotypes of your teacher was explaining a lot of that gap. In the last 2 columns, I'm doing like an exercise that Angris would call like bad controls, something that you are not supposed to do, but I was still interested in doing, because what I'm doing is controlling not only for the test score at the beginning of middle school, but also the test score at the end of middle school. So the test score at the end of middle school is a bad control because, as I showed you before, was affected by having a teacher with stronger implicit stereotypes. However, what you see here is that the effect gets a little bit smaller, at least like with the standard specification, but like more or less is like the magnitude is the same, and there seems to be an effect on top on the actual lower self-confidence of girls that makes me even more worried compared to the results on the standardized test score. So this is like a set of results that was hopefully like I convinced you that teachers matter not only for their like value added, but matters also for their implicit stereotypes, and this could really lead to important implication for the gender equality in the classroom. What I'm doing next. And actually, the final point is that this underconfidence can be activated by the social conditioning. It's not that women are fully innate, like less self-confidence in math compared to boys, but this exposure to implicit stereotype is activating like lower overconfidence of women in the STEM field. Now, what I'm doing next is like thinking about like another side of the problem, and thinking about how does exposure to your peers affect the choice of the field of study. So I'm doing that using like a lab in the field experiment instead of like using like exposure to peers. And the intuition is the following. So what I have in mind is like what we actually did was go to like a set of like schools, do a standardized test score in math and reading with like boys and girls, and try to mimic their choice of like high school, asking them at the end whether they believe like they were better in math, because this is highly correlated with what people end up choosing. So sort of like a comparison between like which field are you better at, and so which field do you want to choose by the end of this task. So here is like what I'm showing you is the probability of choosing math, and there were only 2 fields, so either math or humanistic field. So here you have like 3 groups of students. So the first are students that are better in math compared to humanistic subject, given this baseline like performance. This group are students that are better in literature. This group of students are actually pretty equally good in the 2 subjects. And what you observe here is that, and the black line is for boy, or the black dot is for boy, and the orange one is for girls. You see, among the students that are actually objectively better in math, you see that boys are systematically more likely, 80% of them are going to pick math in our lab in the field experiment, where like 67% of girls end up like picking math. If you take like those that are almost like equally good in the two fields, you see that again, boys, 54% of them pick math, girls, 44% pick math. And in literature, we see like something like, again, very similar. The probability is less than 50%, so it's correlated with their actual ability. But again, boys, like 37% of boys are choosing math and only 18% of girls. And so this like somehow suggests that there could be there is like what we observe in the administrative data, even in our lab in the field experiment, is actually still there. And we find that it's actually correlated with the implicit association test that we have from this student, is correlated with their actual track choice like later on in administrative data. However, let me tell you like what we do in this lab in the field experiment. So this is like the measure that we're going to use, which kind of like a subject do you pick between math and literature. However, we do two different treatments. Before they pick the subject, we are going to tell to a group of them, your choice will be observable to your peers. Not exactly with these terms, it's more simple. It's like there will be we create two parts of the room, saying like math and Italian, and we tell them like this is the people that choose math will bring the tablet here, the people that choose literature will bring the tablet there. So somehow like they know that their peers are going to observe their choice. And our intuition was to somehow replicate in like a school context in an easy way the acting wife like results for like younger kids, and thinking of whether like a social image concern still play a role at such a young age. I didn't tell you, but like the kids in our sample are between grade 6 and grade 8 in the Italian context, substantially middle school. So the second treatment is trying to think about the other channel that I discussed at the beginning in the framework, thinking about not only the role of like social image concern, but also this like systematic correlation that we have in the data, that you pick a field of study and you end up picking also the gender composition of the peers that you're going to work with. And so again, we try to mimic that in a lab in the field experiment, telling them you're going to bring the tablets, the math and literature part, and you're going to work with the peers that are going to choose your same subject for next hour in like similar activities in STEM or humanistic subject. So we are trying to do that, mimicking in like a shorter time period what could be like the choice of the field of study. So what do we find? So the blue bar shows you like the control group divided by gender for males and females, while like the other two bars shows you respectively like the treatment one, so this is a treatment public, the orange bar, and the red bar shows you like this like interaction channel. And what we find is that essentially 47% of like girls choose math in the control group, so independently on the type of information they get, and like we have like almost like 60% of boys that choose math in the control group. How does this like change depending on the information in the different treatments? Well, the acting wife for this like public treatment is not doing much. You see, a little bit it goes in that direction, so there could be a little bit of like a social image concern, but like it's very small, and we are not able to detect any significant impact of the social image concern. So it doesn't seem to be like much of like an issue whether their peers are going to observe that they believe they are better in math or literature. For boys, like you see, the point estimate goes exactly in the opposite direction. If anything, when they know their peers are going to observe their choice, they choose more math. But again, it's not statistically significant. The only part that comes out as like significant is whether your peers are going to observe your choice, plus you have to interact with them for the next hour. If this happens, like girls, like from their probability of 40 percentage point of choosing math, they receive that information, their probability get down to by like a 12.5 percentage point. That is like a 27%. So yes, it's like a 12.5 percentage point decrease in their probability of choosing math. So this is like a first the main results that I want you to bring home from this paper. There are a lot of other stuff inside, but this is like the main message is like, for girls, it doesn't seem to matter much like their social image concern, whether they don't care about their classmate knowing that they believe they are better in math, but they do care if they have to interact with like boys doing the scientific-oriented like task. Now, there are two potential mechanisms that we'll try to go through in the next couple of slides, thinking about two components. So first, think about the perception of like the girls. So we actually asked them, without revealing like the data, we asked them, how many boys in your class do you think choose math? And how many girls in your class do you think choose math? And what we want to see is whether like even conditional on being a girl, the effect that I described before is driven by those girls that believe that there are more boys in math compared to girls. So those girls that believe they are going to be like a minority in the STEM-oriented fields. The second key aspect that we are going to investigate is the friendship network. Because we actually collect very detailed friendship network from these students, and we know we can match them, and we can know the gender of their friends, and we can know which kind of subject their friends choose. Because one other like potential story is that you pick a field where you believe your best friends will be, especially when you have to interact with them. If you have to interact with them, I want to be with like my close like female friends, and so if you have more female friends that are actually in the humanistic fields, you will be more likely to pick the humanistic field. So now here are the results. For the perception, this is like for girls, and here I'm splitting like the girls for those that believe there will be more or less like an equal share or like more girls like in choosing STEM among their classmates. So essentially, those girls that will not be a minority in doing like the task with their classmates. And you see the effect is completely flat. There is nothing going on for them. So if they do, I'm not worried to be a minority, no effect. All the effect, and it gets like pretty large with a reduction of like almost like a 50% is coming like from those girls that are in classes where they believe there will be like more boys. And the effect is actually stable even when I add the class 6 effect. So even keeping constant at the class, if like a girl has the perception that more boys in the class will choose math, the effect is like is extremely large and like close to like 50% of them like giving up in choosing like math. So this, I will come back on this on my conclusion, but I think like in terms of like a policy, this is very important, because if we have this like a systematic association between the gender composition and the field, and this matters for girls and doesn't matter for boys, this implies that girls do not like invest in their STEM skills, not because they don't like STEM, but because they don't like being a minority. And so we could restructure the way in which like schools are organized, like just making sure that they are not a minority, at least like for the great majority of their day, even if they wanted to do a STEM subject in school. So this is the fact for boys. And like we do not find like any statistically significant effect with a pattern that is actually consistent with our prior. But let me like speed up a little bit and tell you something more on like the network data. So the interesting part of the network data is that we actually do find, like as expected and as found in other papers as well, a extremely strong gender homophily. Gender homophily is like the very widespread results every time you work with like network data, especially with like children, and in this case like adolescents, with girls being substantially more likely to be friends with girls, and boys like being more friends with boys, even more compared to other dimensions like socioeconomic status or like or immigrant status. However, this implies that if you are a girl, you are systematically more likely to be friends with other girls, but like if on average girls are more likely to choose a humanistic subject, this could be another channel potentially driving our results. And so the idea is not that I don't want to stay with boys, but that I want to stay with like my girlfriends. That is sort of like, if you want the other side, a little bit of the same story. And so these are two examples of like networks in this classroom. So this is like a more, a network that, where you have like the dot that is like a female, the dot is female, and like the square is telling us if it's math or blue is like female, the red is male, and the circle is like literature, and the square is like math. And so here is like a class where you see there's essentially a lot of like gender segregation. You have like a lot of like all boys that are square, so the all boys are in math, and like the girls that are all in humanistic fields. And while here you have like actually a very interesting like a class combination where you have like a dot, this a square that is this girl that is like interested in the scientific fields, that is the dot between, that is like very likely to be friends with boys, but also friends with like other girls as well. So there is like, it shows a little bit like two different like type of network structure that could be potentially affected, and explain these results. And what do we find on this? Again, like we can't rule out that this channel as well. So this seems to be like also something like driving the results, even if like slightly smaller compared to the perception of the peers. But you find that again, the results are not there for girls that have more friends that are in math. And the results are actually more negative for the girls that have like more friends that pick literature. So again, it doesn't allow us to rule out one of the two stories. Both are at play at the same time. And for boys, nothing going on. So it doesn't matter. So their choice of the field study is not affected by this component. So just summarizing like the result of this like second piece of work that I wanted to discuss here. So we find this like a suggestive like evidence that the choice of the field of study is actually influenced by your peers, and knowing in particular that you will have to interact with your peers, not much by social image concern of like their peers observing that you are actually more interested in the STEM fields. And we do find that like both like the two mechanisms that we investigate, the perception of like how many peers will choose like math by gender, and also like the choice of like your friends, are both explaining like part of our results, even if the first one, the former one, seems to be like more important in explaining the final result. Now, in the final part of this talk, I'm going to think about like some of the intervention, and one is like a sort of like we're waiting for the last round of data, but it's like a sort of like a concluded, and one that is more in progress in thinking how to mitigate like gender bias like in school. So one of my other paper that I didn't add here because it's like it's more an immigration focus is trying to think about how can we increase implicit stereotypes, so we can decrease stereotypes in schools by increasing awareness of teachers on their own implicit stereotypes. And this is like another type of intervention that especially in countries where implicit stereotypes are not widely diffused as Italy, and I guess like in part like Spain, it could be like a very effective intervention, and this is what we show in this paper. But today I'm going to focus on two other alternative intervention. And the first one actually came from when I was collecting the data for the previous paper that I discussed today. And I was like, I went myself to almost 100 schools spread out across Italy. I was talking a lot with like the teachers. And what came out is that there was like a private agency that was trying to do like a match of like for example Microsoft, like high level like STEM employers that were entering into the Italian market and really wanted to set up like establishment. But like they wanted like gender equality in terms of like a participation in the labor market. They didn't have that. They couldn't find like applicants with the right set of skills, even trying to interview as many as possible, because essentially the system is so segregated that when you are 14 years old, you choose to not attend like the scientific high school, and therefore like you accumulate a different set of skills. It was very tough for them to find like the number of applicants even for the position that the sort of like the firms they were working with, like were trying to target. And so what they decided to do is like invest their social capital into like a coding clubs for girls during middle school. The first year they did that, it is like an interesting anecdote that I couldn't evaluate because I didn't have the data, but the first year they actually did coding clubs for the entire class with like a gender mixed in the classroom. However, after like few months, like they were saying like this is like definitely not working. Boys were essentially taking over the entire clubs, like these coding clubs, and like they were deciding like the entire project. Girls were somehow like switching off their brain, and they were not really participating actively. And so this pilot that they did was completely ineffective. So I tried like to convince them, like when I entered the project, it was like, why don't we like try to vary that, try to see whether it's like better to do like a gender mixed environment or like a gender specific like environment. And they were like, no way, we tried once, no way that we're gonna try again, because it really doesn't work. But I feel like even this anecdote is interesting, like to see how like even like anecdotically, how these like perception were really different in, or like how these like perception, or even of like an NGO that entered this program, like investing their social capital, trying to be, trying to promote like coding as STEM in like in middle school, they were like, this is definitely like leaving aside like half of the population, because they are sort of like not engaged, like since like the beginning, because of like this taking over. So these like, there are some studies on single-sex schools, a few of them, so I feel like it should be more. But right now, for example, in the US, they're getting way more common over time. And so I feel like it is a very interesting like area to study, especially when people are forming their identity and like the association between different fields. Say that, like what I find like interesting of these coding clubs, probably except the name, so they call it, like after the first year, they decided like to call it Girls Code It Better, in Italian, like they use the English name, but the name I feel like is not the best thing of like the project. But what I find is extremely fascinating is that they're a firm that's trying to match like people in the labor market. And their intuition is like, we really need, is actually going back to David Deming, like work on social skills. We need people that have like math and coding skills, but we need people that like know how to manage project and have like develop like their social skills. So this entire project is really based like not only on coding, but really seeing like this association and developing like a project-based like learning method, developing like social skills and like ability to work in the team, to figure out like what you want to do and like develop like the entire project. Okay, and so what I'm gonna show you today is like who are the girls that actually self-select in this club, and I'm gonna come back on why this like I think matters. And the second key question that I'm gonna address is like how these like coding clubs had actually an effect on student outcomes. Okay, so first, a little bit more about like these coding clubs. So the idea, as I said, was coming from this private employment agency. They target like middle school girls, like they are between 11 to 14 years old, the same target of like the rest of this presentation. And they send like one coach maker, it's called, so someone from a local firm that is actually like trained in order to develop like this type of project. They actually really work with like local firms. So let's say that if they want to do 3D printing on some product, they actually do it. Or like if they do like some coding, they actually go back to the firm to do it like in collaboration with them. It's completely free for the girls, and it's done in the afternoon for like 45 like meetings throughout like the academic year. So it's a pretty intense like program, and they try to develop like coding and new technologies from automation. They did like robots, 3D printing, like they design app. So these are the type of intervention that they develop. It's based on a lot of teamwork. So each school has one club, and they develop like one project, and the girls needed to in the first like task is to coordinate and like understand how to choose which project. And so there need to be something that has like a social impact and can be seen by their classmates. So it need to be something that shows like shows how visible like these so makes it like visible how the coding work of these girls could have an impact on the society. So this is an example, like we organize like an end of year conference. Well, all these girls from all over Italy actually come to Bocconi University, that is one of the most like famous private Italian universities. They do come, they bring their own project. So these were like some example of like the project that they did. And the first like there is like some sort of like a networking event, and then they have also this show off. So they have all their desk where they show off like their product to people that like walk around the university. So the data I'm going to show you comes from two different sources. One is like a standardized, one is like a survey data that we collect at Endline from all the students in the schools, because we do the survey as if it was not part of like these Girls Coding Better like a program, but it's like more like open to all the students participating. And we have administrative data from the standardized test score to like a track a choice of like the field of study. So here you see, so there was among like so what I was able to do with this like a private labor agency, I was able to convince them to allow all the girls to the school to apply, and then randomize like the girls that enter in one specific year, conditional on the application. So I can show you like both how they compare like the girls that apply to the project compared to the other girls in the same schools, and how this project could actually have an effect. So you see the characteristics are overall like balance between treated and controls. And so in terms of like self-selection, we do find that a bit surprisingly, the fact was not huge in terms of like parents' education. So they have like a little bit more parents, like mothers, especially working in STEM. I was expecting that the girls that applied were only from like mothers working like in STEM. Is a little bit more. So you see like, for example, like the one that apply have like mothers with like medium to high wage. They work a little bit more in STEM, but like it's like very small. So my big takeaway is that like there is no statistically different effect, except for like the immigrant. That is like one of the most striking results, because there is like an additional cultural barrier at this intersection between immigration and gender in getting like into STEM fields, or like a more advanced career, or like even going like to school in the afternoon afterwards. So something that we do find like quite some difference is like the girls that apply are more interested in STEM occupation, but the gap is not there. There are still like a lot of girls that do not apply, but they are interested in STEM. Where there is the highest like gap is actually in the feeling that they are unfit in general for that occupation. That is interesting that they apply to these coding clubs that are only for girls. So now I believe that I like STEM, but if I believe that I'm unfit with like STEM, now I apply to these like coding clubs that they are in a protected like environment with only girls. Well, like in other cases, I could like do other activities in my afternoon that could be more gender mixed. But in these are the girls that get attracted the most by this type of program. Now let me like wrap up pretty fast, given that I want to keep like some time. We're discussing to have like some time for questions, but I just wanted to show you like a few results. So the main like treatment effect is what you see in the first two columns. So this bar here is like what's the probability of choosing a scientific high school for the girls in the control group, and this bar here is the probability of choosing a scientific high school for girls in the treatment group. So you see that it goes from 11 percentage point to 29 percentage point. So their gap is pretty large. So in part, I was surprised this gap, and this probability was very low of like girls in the control group of choosing like a STEM. The confidence interval are large. We were still waiting like for one additional year of data. And you see it's like overlaps with the confidence interval for other girls in the school. But these girls, the treated one, like now have like a probability of attending STEM that is even higher compared to boys on average, with the standard errors that like overlap with the mean for boys, that is the last bar. So somehow like this shows like promising results on like pushing like a lot of girls like into STEM since like a high school. We have like a set of results on other like non-STEM occupation, but like something that I really wanted to show you is from the survey data in their perception of their own gender being unfit with their occupation. And I told you this was one of the dimensions where we see these girls that self-select into our only single-sex schools were driven by interest in STEM, but thinking that STEM was like not a good match with their own gender. And we do find that this is like one of the dimensions where we correct that perception the most. And so you see that like girls like in the control group have a much higher perception that the gender is like unfit compared to like the girls in the treatment group by the end line point. So this like somehow suggests that they enter the project with like this strong like perception that STEM is not a good fit for women and they want to do STEM, but they exit the program like feeling that STEM is actually the right place for women. In the last second, I wanted like to just like tell you a little bit about how I'm thinking moving ahead in this like research agenda. And we are thinking about like now using, like now we have like this universe of administrative data that we follow every year of like throughout their school career. And like these data, what is like a fun, like interesting is that they are available for us now at this point as like a researcher, but there is no giving back to schools. The schools don't even have an idea when I show them these things. So this is like the teacher assigned grades and the probability that a teacher is a version of what I showed you at the beginning, but now I'm using like the teacher track recommendation. So this is the field of study that the teacher recommended to the student. And when I go to schools and teacher and show you that like, well, look, if you take the student that you gave them like a 10, that is the highest grade in math, you systematically are less likely when it comes to something that is relevant for their future, when it comes to choosing like their field of study and investing further in the STEM education, you see that systematically boys have like a probability that is 1/3 higher of being recommended by their own teacher, even conditional on their ability and teacher assigned grades of being recommended to a top-tier track. And when I talk with teachers, they are kind of like, whoa, this is strange, this is like not possible, that this is me, this is not on my students. So right now we are giving them reports showing them their gender gap in the past track recommendation. So this is a way that I think is like important as a researcher to think how can we give back to the people and maybe in this way like increase awareness, because this is something like teachers do not want this gap. It's just like when they give the track recommendation, and actually my job market candidate, my PhD student, Francesca Miserocchi, that is currently on the job market. So if you're still like thinking to send out interviews or if you're interviewing there, she's like amazing. But her intuition was actually, for example, that memory is one of the key ideas that matters in this, and the cognitive load that the teachers have when they give this track recommendation. And here what you see is like a completely her work. This is like nothing to do with me. But like what you see here that I find like extremely fascinating is that she does an experiment when she changes like the cognitive load of individuals. And when teachers have a higher cognitive load, all the gaps emerge. And what is what you see here in terms of like the gaps in track recommendation. For those that do not have cognitive load and have all the information when they give the track recommendation, there is actually no gap. Like one example, like her paper has a lot more inside, but like I think like there could be reason why these teachers and in general civil servant individuals that are doing screening of CV, they have like so many things going on at the point in which they are taking like this important decision, and they are not fully aware of like how these sort of like implicit bias and like cognitive load interact, these stereotypes interact in leading to the undesirable outcome for our society. So I really think that here is like a setting where machine learning in helping them to predict which is the right track for the different individuals independently on gender could really help in shaping the future. So 10 minutes, like including question, right? Okay, perfect. So I'm gonna, I promised to keep it like to 40 minutes. I was clearly not at 40 minutes, but at least we have some time for questions. So let me stop here and like just make sure that I have some time like to take questions before we wrap up.
Now I have a question. Okay. I have a general question and a kind of specific question related to it. So the general question is about the role of comparative advantage. So For example, the figure that you showed in the end with respect to the teacher recommendations. I mean, of course, the recommendations should depend not on absolute performance, but sort of on comparative advantage of the student. And I would guess that if you would compare girls and boys who have the same performance in math, chances are that the girls are on average better in other fields. And so, what do we know about sort of comparative advantage?
Yeah.
And the specific question related to that, when you looked at these teacher biases, so it's clear that these negative effects on girls if you have like a biased teacher, but are there some cross effects? Is it maybe that to some extent people just reorient their efforts to other subjects? Is that something you looked at or you could look at, or you think that whether that might play a role? Thanks.
Thank you. Thank you for both questions. So actually, if I do the same figure that I was showing you here, dividing like by socioeconomic gap, you actually see that most of the gaps come from like the high income families. And this was like because like the low income family, they have essentially very low probability of sending like both boys and girls to the STEM track, because in the Italian context is like felt like a little bit as like the top tier class. So even there is a second cross problem that low SES people are less likely to be sending STEM. However, like I feel like the overall gap was there like for both groups. It's simply like that a lot of like the top the people that are able to get a 10 and they are more likely, systematically more likely to be from like a higher socioeconomic status. However, I really think like parents matter a lot in this choice, and I have another separate paper. I didn't add it here. At the beginning, I was thinking to talk about teachers, parents, and peers, but I just like cut it like the parents part, because in some sense it's like the less strong. The result that I have like a little bit like less strong, but what we do find is that we do in that lab in the field experiment that I told you about, when they have to pick in two fields, math or humanistic subject. If we tell them like, now think about your mom recommendation before they choose their field of study, or think about your dad recommendation. What we find is that for girls, if they think about their mom recommendation before choosing, they became substantially more likely to choose humanistic subject. If they think about their dad, boys became more likely to choose STEM. So there is like this cross interaction between the gender of the student and like whether they think about their mom. So the mom seems to have like a higher influence in pushing girls into humanistic subject, while like the dad has a higher influence in pushing boys into scientific subject. So this is like in part like somehow related to your concern, and I really think that more broadly, like parents do play an important like a role on this. I just had a very hard time working with parents when they start to be like from middle school on. When it's like elementary school, I think it's easier. When you start from middle school on, it's like much tougher to get, or at least I had like a harder time getting like a high quality data from parents themselves. From the second part of your questions in terms of like a comparative dimension, I feel like there are actually a couple of papers, and if I remember correctly, I feel like Thomas Breda has like a very nice paper on thinking about like the comparative advantage in different fields, because girls are substantially extremely good in reading, and or like put it in the other way, boys are extremely bad in reading. So in comparative terms, like girls are much better in readings compared to boys, and so let's say that you need to recommend a bunch of students to different tracks, and you see that girls are systematically, they're good in both subjects, and so, well, like boys are systematically better in math, so you're gonna push boys into math and girls into humanistic subject, and this could make sense if there was no differential returns in different tracks, but if they are equally good in math and there is differential returns in the different tracks, it makes me a little bit worried that this is not like socially optimal.
So thanks, Michela. This is fascinating work. So I found particularly interesting the effects on the network and how you emphasize the importance on that. But that would have very specific policy recommendations. No, you could play the network to your advantage. So actually, when I saw that you had the project on coding, I was thinking whether you could, if you bring the right girl, like the central in the network, to the coding, and you make her like more STEM fancy that might drag the peers, right? So have you thought about that, or is there a way you
This
could
is a
test
great
it?
idea. Actually, we could definitely do that, but haven't done it. It makes me think about like Eliana La Ferrara has some recent work in Brazil in which they try to target like information to the central. They collect first a network and they targeted information. So I think this is like a very promising way of like try to attract the most like prominent girls into STEM and like try to leverage that. So I feel like it's actually a great idea. I haven't done that.
That was extremely fascinating. Thank you so much for sharing your work with us. I've always been favorable to co-education, but your research seems to bring bad news to co-education. So I was wondering if you could elaborate a bit more on that and whether there's any evidence of whether girls they are more likely to choose STEM topics in schools that are segregated, and whether there is a trade-off, meaning maybe the interaction between boys and girls on other dimensions is positive and might compensate for this?
Yeah, so to be honest, I see this as a very open research area that I know a couple of papers in that direction. One was in the UK context that was showing like some promising like a push in that, and one was more like comparison across countries where you see like that there are more schools that are segregated, and you see that like actually more girls like enter into STEM. Think about like Middle Eastern countries that do have like a school segregated, and they do have like quite a higher share or like women into engineering, for example. So I feel like there is some correlational evidence in that direction and some attempt. I would say like in the US, I feel like there is a very good opportunity right now because single-sex schools start to be extremely widespread, especially in large cities. And I have like, even among my colleagues, a couple of them recently came to me and say like, look, we decided to take out like our daughter from like a co-ed like a school because she got like this strong message from their peers that like she's not good enough in math. And now before she really wanted to do math and now she doesn't. So these are like very anecdotal experience, but like in the US, like I know a lot of like professors that do have like their daughters in a single ed school, and so the overall like implication for the society is something that is unclear. I think like. So that's why like I don't want to say that there is like definitely evidence. So I feel like it's an open research area that it could be like very interesting to explore more. So what I think like is fascinating is like the period of adolescence is really key for in terms of like brain development and like identity formation. And so it could be like the key point in which you really want to just make sure that people do not, especially in a society that has a high level of stereotypes as our society, you just like may want to be particularly careful, and like it may be like a particularly good time to protect individuals from those stereotypes at the point in which they are making very important human capital decision as like the choice of like how much to invest in STEM. However, still open, so I would love to see like even more research on this.
Thank you. Thank you, Michela, for a very interesting talk. And I apologize if I have asked you this question before. So my question is, we take it as given that these STEM-intensive jobs have very high returns. Let's say, I mean, observably they pay higher wages than other types of jobs. But I haven't seen a lot of causal evidence that, you know, pushing these marginal girls into STEM, whether their returns to, you know, switching from STEM to whatever they would have done otherwise, that this really has, you know, the high returns that are suggested by the descriptive, you know, just comparing wages in STEM. So are you planning on, because you are pushing these marginal girls into STEM, are you planning on looking at their labor market returns?
Yes, we are working on the agreement now, like, because right now we are up to the education data. Now it's too early for them, but like I'm working on the agreement for this project, but more broadly, and so this is like something that I think is like part of my battle. I've been working a lot with like different offices in just like making sure that we could merge like the data. For example, like education data, labor market data should be something that should be for these type of questions, but like more broadly for any other question you may have on the long-term returns. of project or education in general, it should be really pushed like forward more. And so this is like a context in which I feel like we're getting close. We still don't have like the agreement signed, but there is like everybody's proprietary of like their own data, and they don't want to for their own data to go to the other institutions. So right now, like we are trying to find like middle grounds in order to be able like to do that. But there is like a way around that, and the data are structured as like the Nordic country to be able like to follow that. You have the identifier. I'm sure like in Spain is the same, and actually we had some discussion yesterday about that. It's just like a matter of like a political will of like making sure that this happens. And so I really hope like for Italy, for Spain, that we really change the way in which we approach the merging of data across different contexts, because this will be the only way to answer this question in a causal way. The work that I cited from David Deming that shows like these strong returns from STEM, but even higher from this combination of like social skills and STEM, this is like still correlational evidence, exactly as you were pointing. We need like more to just like make sure that this is like this will have like a very positive effect, and they will not be penalized when they enter in the labor market because of like their interaction. So again, like an open area, I feel. Thank you so much.